For this part, what you're going to be discussing is going to be your number patterns. In terms of number patterns for grade 11, they are going to be divided into two parts. First, you're going to have your linear patterns. We are going to be discussing your linear patterns in detail. First things first, you need to be able to know that it is going to be given by the easiest possible formula, which is going to be dn plus c. Throughout all of this, you should be able to know that d is going to be referred to as your common or constant difference. In order for you to be able to find your common or constant difference, you need to be able to go on and say that d is equal to term number 2 minus term number 1, which has to be equal to term number 3 minus term number 2. With this, it means that both values that you get for the subtraction of these terms has to be equal. If that is equal, you therefore end up with a constant or common difference. In order for you to be able to find in order for you to be able to find C, you therefore go on and say that this is going to be as follows. You are going to sub in a value. You sub in a value that is given. So in this instance, we can go on and say that you can go on and sub in term number 4, which would have its own value. So roughly, let's say term number 4 is 8. So it means that you're going to go on and sub in that term into the equation that now has a difference for you to be able to find your C. In order of this, we can be able to do a practical example. For our practical example, let's go on and use the following. We are going to use this, which we're going to say that we're going to have, let's say 2, 7, and then 12 and 17. With this, we'll be able to go on and place it as follows to say that we need to be able to find our difference first. Our difference is going to be given as follows to say that it has to be term number 2 minus term number 1, and then term number 3 minus term number 2, as well as term number 4 minus term number 3, which then means you end up with the following. It is going to be 7 minus 2, which is going to be 5. Then you end up with 12 minus 7, which in this case would give you a different value, if I'm not mistaken. Actually, same value. So it is going to be 12 minus 7, 12 minus 7, which is 5, and then 17 minus 12, which is 5. This then means that you have a common difference because after subtracting all your values, the higher term minus the lowest term, you then end up with 5. So as a formula, you're now going to say dn is going to be equal to 5n, and this is going to be plus c. You now have to go on and find the value of c. I am going to be picking the fourth term in this case to say that term number 4 is going to be equal to 17. So I'm going to say T4 is equal to, wherever there's n, I'm going to substitute 4, making this 5 by 4, then plus c. I do know the value of term number 4, that it is going to be 17. So I can be able to place that 17 to say that 17 is equal to 5 by 4, which is 20 plus c. In order for me to be able to get the value of c, I can therefore go on to say that this is going to be 17 minus 20, which is equal to c. Therefore, c would be equal to -3. If I have to write this as a complete formula, it then goes on to say that tn would therefore be equal to 5n minus 3. And just like that, you now have your equation for a linear pattern. Moving on from here, we therefore go on and talk about the next type that you're going to be dealing with. The second type of pattern that you'll be dealing with is going to be a quadratic pattern. In terms of a quadratic pattern, this is basically the one that is most important for your particular grade. Starting off here, we can be able to go on and place the following to say that the main equation that you're going to have, or the general term in this case, is going to be Tn is equal to an squared plus bn plus c. With this, you are going to have Tn representing your general term. As given by the general term, you can therefore be able to go on and find a, b, and c. The best way for you to be able to find this is to go on and say that 2a would be equal to your second difference. What separates a linear and a quadratic is the fact that a quadratic is always going to have an equal second difference. Equal second difference. Whereas you have a linear that has a equal first difference. So in order for you to be able to find specifics, if you're looking for A, it is going to be 2A is equal to the second difference. If you therefore go on and look for B, it is going to be as follows, to say that B would be 3A plus B is equal to the first difference. So this then means that in order for you to find B, you're now looking at, you need to be able to have A first, then whatever you have is now going to be 3A plus B is equal to the first difference. Then last but not least, you therefore have to go on and find C, which is now going to be A plus B plus C is equal to the first term of the pattern. First term of the pattern. We can then take all of this and put it into a practical example. For our practical example, we are going to use the following to say that, let's say we now have this. In terms of the practical example, let's go on and use something basic such as 6, 17, 34, and 57. With this, we would be able to find everything. So first thing that we're going to do is we're going to find our first difference. The difference order hasn't changed. It's highest term minus the lowest term. Now, when I say highest term, I don't mean highest value. I mean highest term, meaning that T1, T2, T3, and T4. So it is going to be T2 minus T1, T3 minus T2, and T4 minus T3, irregardless of the values that they have. So in this case, we're going to end up with the following, to say that it's going to be 17 minus 6, which is going to give us 11, 34 minus 17, which is going to give us 17, then 57 minus 34, which is going to give us 23. That is going to be our first difference. As you can see, the first difference is not the same. If it is not the same, it gives you an idea as to say that it is not going to be linear, it is going to be quadratic. With that, we can therefore be able to go on and place it as follows, to say that we're now going to do the very same highest term minus lowest term. So in this case, it's going to be T2. So this now becomes T1, T2, and T3. T2 minus T1, which is 17 minus 11, will therefore give us 6. Then T3 minus T2, which is going to be 23 minus 17, gives us 6 as well. We can then take all of this and place it into our equation for us to find A, B, and C, which means 2A would be equal to the first, which would be equal to 6 there, which is our second difference. We can therefore also go on and say 3A plus B is equal to 11, which is our first difference. Then we can say A plus B plus C is equal to 6, which is the first term of the pattern. With all of this, we can therefore be able to go on and solve individually to say that if we're looking for 2A, 2A is going to be equal to 6. Therefore, dividing both sides by 2, I'll be left with A is equal to 3. With that, we can also go on to say that you also have to say 3A plus B is equal to 11. So it is going to be 3 by 3 plus B is equal to 11. Therefore, B is equal to 11 minus 9, which is going to give you 2. Last but not least, you can therefore go on and calculate for the A plus B plus C is equal to 6, which is the first term of the pattern. Then after that, so to specify, the 6 that I'm using are those ones there, which means that you're going to have A plus B plus C is equal to 6. Your A is 3. Your B is 2, your C is unknown, equating to 6. 3 plus 2 is 5. Therefore, you move the 5 to the other side of the equal sign. You're going to end up with 6 minus 5, which then gives you to say that C is equal to 1. As a complete equation, this is what you're now going to end up with. You're going to take all 3 values that you found and place them into one equation, which is Tn is equal to An squared plus Bn plus C. With all of this, it is now going to be Tn is equal to 3n squared plus 2n plus 1. And this becomes your quadratic formula for this particular equation that you would be given. Continuing from there, there is a very common question that you are going to be asked. Now, this is based on the fact that you might have a missing value on your given terms. So let's take a practical to say that in terms of this, you are given to say that you have a quadratic pattern. So let's say, given a quadratic pattern, of, let's see if we go with 6 by 15, just fixing my pen, 6 by 15, then x and 45. You are then asked to be able to find the value of x. Now, you are told at the beginning that this is actually a quadratic pattern. If it is a quadratic pattern, it then means the most important thing that you need to be able to know based on a quadratic pattern is the fact that the second difference is equal. So it means that this is how you'll be able to work it out. We're going to take it on to say that it's going to be 6, 15, x, and 45. We are going to find our first difference using highest term minus lowest term. So we have T1, T2, T3, and T4. We're going to go on and say T2 minus T1, which we're going to end up with as follows, to say that this is going to be 9. Then we're going to say T3 minus T2, where we're going to end up with x minus 15. We then go on to say that it is also going to be T4 minus T3, where you're going to end up with 45 minus x. We then take all of this, and that is just the first difference. Once the first is done, we go on and we calculate for the second. Our second difference would therefore look like this. It is still going to be highest term minus lowest term. So that's T1, T2, and T3. It is now going to be T2, which is x minus 15, then subtracting the 9. Then we go on to the next one to say that it is now also going to be T3 minus T2, where you're going to end up with 45 minus x, then minus x minus 15 there. We always add our brackets so that we're able to distribute the negative that is outside and not miss a sign. So most importantly, we now have a second difference. For our second difference, what we know is every term in the second difference has to be equal. So we therefore go on and say that the two terms that we have in this case, which is T1 and T2, have to be equal, which then means we can go on and say x minus 15 minus 9 has to equate to 45 minus x minus 15, which then means we can now go on and say that this is going to be x minus 24 is equal to, oh, my apologies there, I forgot to distribute. So we're going to distribute that as well as that, meaning that our 15 would then change to a positive. This then means that you're going to end up with 45 minus x plus 15. As a calculational measure, we can now go on and say that this is now going to be as follows, to say it's going to be x minus 24 is equal to 60 minus 2x, where you would end up with the following, to say that that is now going to be 3x, numbers with numbers, variables with variables, and that is going to be 84. Dividing both sides by 3, you should be able to be left with x is equal to 28, if I am not mistaken. So it is actually going to be 28. Once you have that, it then means you have now found the value of x. The whole process can be repeated based on what you have. Once you find one value, you can therefore go back and substitute it to be able to find any other value that you are looking for. And just like that, that is how you do your quadratic equation.